We zoom out into the immense,
In
seemingly
the unending
empty
silent
blackness of
darkness
interstellar
between the
space.
stars, time itself seems to hold its breath. This is the great void, the cold and tranquil abyss that separates the islands of light we call solar systems. For eons, it has been a realm of profound emptiness, traversed only by stray photons and the faintest whispers of gravity. Humanity, from its lonely perch on a small blue world, has gazed into this immense expanse for millennia. We have charted the constellations, measured the distances, and listened with electronic ears for any sign that we are not alone. The silence has always been the deafening reply. We believed these interstellar gulfs to be nearly barren, imagining that a traveler from another star would be an event of mythological rarity, an occurrence not to be expected in a single lifetime or even in the entire span of a civilization. Then, in the autumn of 2025, the impossible happened. From the direction of the constellation Telescopium, an anomaly designated C 2025 T4 streaked into our celestial neighborhood. Its trajectory was a perfect hyperbola, a gravitational signature that screamed its alien origin. The world was electrified. A visitor from another star system, the first of its kind to be so clearly observed, had arrived. Scientists scrambled telescopes, refocused, and humanity collectively held its breath, witnessing a cosmic lottery win. It was a moment that redefined our place in the universe. We were no longer just looking out, something was now looking in. But this singular civilization, defining event, was merely the prelude. The universe, it seemed, was not finished with its revelations, because just 89 days later, it happened again. From a completely different sector of the sky, a second traveler appeared. This 1C 2025 V1 Borisov was fainter, moving faster, and its path was even more steeply angled against the plane of our solar system. It was another definitive, unambiguous interstellar interloper. The cosmic lottery had been won twice in the span of a single season, and with this second arrival, a quiet, thrilling and terrifying question began to form in the minds of astronomers and thinkers across the globe. A question that cascaded from observatories to laboratories, from hushed academic conferences to the highest corridors of power. The stupefying statistical unlikelihood of such a coincidence forced us to confront a profound and unsettling fork in the road of cosmic understanding. Are we witnessing an episode of astronomical luck so improbable it borders on the miraculous, or is this something else? Is this a message, a survey, a precursor? Is this arrival a deliberate act? To comprehend the sheer magnitude of this cosmic coincidence, one must first appreciate the scale of our cosmic isolation. Imagine our sun is a single grain of sand on a vast empty beach. The nearest neighboring star, Proxima Centauri,
it's showing
is another
signs
grain
of
of
intelligent
sand,
design.
located 4 kilometers
It's definitely
away.
not an asteroid.
The space between them is the interstellar medium, a near-perfect vacuum, unimaginably vast and desolate. For an object to be ejected from one star system and by pure chance travel for millions of years to pass through the tiny gravitational sphere of another is an event of breathtaking improbability. The Oort cloud, the theoretical source of our own long-period comets, provides a useful mental model. Picture our solar system not as a flat disk, but as a colossal spherical kingdom. The castle at the center is the Sun and its planets. But surrounding this central keep, extending out for nearly a light year in all directions, is a ghostly scattered realm of trillions of frozen bodies. This is the Oort cloud, the most distant and tenuous frontier of our Sun's dominion. These icy remnants are so loosely bound by the Sun's gravity that the slightest perturbation can send them on new paths. A passing star, a nudge from the galactic tide, can act like a gentle breeze shaking the outermost branches of an immense invisible tree. Occasionally an apple from this cosmic orchard is dislodged, and begins a 100,000-year fall towards the Sun, becoming a spectacular comet. More often, however, that same celestial breeze can shake an apple loose with just enough force to break it free from the tree's influence entirely. It is cast out, sent tumbling into the dark forest that is the Milky Way galaxy. Every star system is believed to have its own version of this celestial orchard, and for billions of years this process of ejection has been seeding the galaxy with these lonely wanderers. The galaxy is a forest filled with countless trees, each constantly shedding its fruit into the darkness between. Our solar system, in its journey around the galactic center, is perpetually moving through this sparse, invisible blizzard of vagabonds. Calculations based on the discoveries of Oumuamua in 2017 and the first two Borisov in 2019 suggested that our system might sweep one up every decade or so. The arrival of C 2025 T4, while exhilarating, fit neatly within this upgraded forecast. It was a spectacular but understandable event. Its composition was exotic but recognizably cometary. It was a natural wonder, a testament to the dynamic and interconnected nature of the galaxy. But the arrival of a second object C 2025 V1 Borisov from a completely different direction, and so soon after the first, shattered those comfortable models. The odds against two such independent travelers originating from different stellar nurseries and wandering the void for untold eons, just happening to intersect our tiny corner of space within the same 3-month period, are not merely astronomical, they are hyper-astronomical. It is like standing on that 4-kilometer beach, picking up a random grain of sand and finding it was the very grain you lost on a different continent a year ago. Then a minute later, a seagull drops another grain of sand at your feet, and it's the one your childhood friend lost on yet another continent 20 years prior. At some point, you stop marveling at the luck. You start looking for the person playing the trick. The story of the second visitor begins where the story of the first real interstellar comet did, with a man named Gennady Borisov. A Crimean amateur astronomer and a former engineer at a state astronomical institute, Borisov had become a legend in the comet hunting community, working not from a state-of-the-art facility but from his own personal observatory, Margot. He had a knack for finding the unusual. He had already cemented his place in history with the 2019 discovery of 2I Borisov, the first object to be confirmed as both interstellar and clearly cometary. 5 years later, he was still at his post, a patient sentinel scanning the celestial sphere. On a cold November night in 2025, his custom-built telescope captured a faint, fuzzy smear of light in the constellation of Cepheus. It was unremarkable at first, just another suspect on a long list of potential near-Earth objects. He followed protocol, uploading his findings to the Minor Planet Center, the global clearinghouse for such discoveries. Other observatories, both amateur and professional, swiveled their immense eyes to confirm the finding. The initial orbital calculations were routine, but as more data points were added over the next 72 hours, a strange and familiar pattern began to emerge in the numbers. The eccentricity of the object's orbit, a measure of how much it deviates from a perfect circle, was not 0.9, nor was it 1, it was 3.7. An eccentricity greater than 1 signifies an escape trajectory, a hyperbolic path. This object was not from around here. It was moving far too fast to be captured by our sun's gravity. Like a bullet fired from an unseen rifle in the depths of space, it was merely passing through, destined to return to the cold abyss from which it came. The news spread through the astronomical community, not like a fire but like a shockwave. Disbelief was the first reaction, a software glitch, a miscalculation. But the data was undeniable, confirmed by instruments in Chile, Hawaii, and in orbit. The world had barely processed the implications of the first visitor C, 2025 T4. Now, there was another, and its discoverer by an almost poetic stroke of fate was the very same man who had found the first confirmed interstellar comet years before. The name was affixed C, 2025 V1 Borisov. The cosmic coincidence had just acquired a layer of profound human irony. Immediately, the scientific world split into two broad competing schools of thought, each scrambling to explain the inexplicable. The first camp, grounded in the principles of caution and conservatism, sought a natural explanation. They argued that our understanding of the galaxy's dynamics must be fundamentally flawed. Perhaps they posited interstellar objects are not lonely solitary travelers at all. Maybe they travel in swarms in great scattered flotillas. This flotilla hypothesis suggests that when a young star system is forming, the gravitational chaos is immense. The adolescent gas giants migrating in their orbits can act like colossal slingshots, ejecting not just one or two planetesimals, but entire clusters of them in the same general direction. These swarms, bound by their shared origin, would then travel together across the galaxy for billions of years. A loose, invisible river of ice and rock flowing through the interstellar void. Our solar system in this scenario has just unwittingly blundered into the path of one of these ancient streams. C, 2025 T4 and C, 2025 V1 Borisov are not two separate, unrelated miracles. They are merely two pieces of driftwood from the same distant primordial flood. It's a compelling idea, one that preserves a naturalistic worldview. It suggests a universe more cluttered, more interconnected than we ever imagined. Another possibility is a more local disturbance, perhaps a star, relatively recently in cosmic terms, passed unusually close to our own. Such a stellar flyby a few 100,000 years ago could have gravitationally perturbed the outer Oort cloud in an unprecedented way. This gravitational tide could have shaken loose a cascade of our own comets, while simultaneously focusing or deflecting a stream of incoming interstellar objects that were already in transit. We aren't seeing more visitors. We are simply in the middle of a temporary cosmic traffic jam caused by a long-vanished passerby. The most sober explanation, however, is perhaps the most humbling, a simple matter of observational bias. Humanity has only just in the last decade developed the tools to systematically scan the entire sky with the depth and frequency needed to spot such faint, fast-moving intruders. Projects like the Pan-STARRS survey and the newly operational Vera C. Rubin Observatory in Chile are charting the heavens with unprecedented acuity. These systems are not just telescopes, they are data-devouring machines photographing the entire visible sky every few nights and using sophisticated algorithms to detect anything that moves or changes. The argument here is that these interstellar objects have been streaming past us all along, perhaps one a year unnoticed. We didn't suddenly get lucky, we suddenly got good glasses. We've spent our entire history living by a roaring invisible highway completely oblivious to the traffic. Now that we've finally built a lookout tower, we are stunned to see the cars go by. The close timing of the two 2025 visitors in this view is simply a statistical fluke, a clustering that is bound to happen sooner or later once you start watching. It's the scientific equivalent of it's just a coincidence. But for a growing and increasingly vocal second camp of scientists, the coincidence explanation felt intellectually insufficient. The sheer improbability was a signpost, a clue so enormous it could not be ignored. They argued that to dismiss the timing as mere chance was to abdicate the scientific duty to investigate anomalies. And C, 2025 V1 Borisov was more than just an anomaly of timing. As the world's most powerful instruments focused on it, the object began to reveal characteristics that strained the definition of natural. The first peculiarity was its trajectory. Like Oumuamua before it, the object exhibited a tiny, almost imperceptible non-gravitational acceleration. It was deviating from the path dictated by the sun's gravity, but only by a minuscule amount. With a normal comet, this is easily explained. As the sun heats, the icy nucleus jets of gas and dust erupt from the surface, acting like tiny rocket thrusters that gently push the comet around. But the outgassing from C 2025 V1, as measured by spectrographs, was far too weak and too symmetrical to account for the observed course correction. It was as if the object was making a deliberate, impossibly subtle adjustment to its path. The second oddity was its light curve. As an object tumbles through space, it reflects sunlight, and its brightness, as seen from Earth, fluctuates. A potato-shaped asteroid will have a simple, predictable rhythm of brightening and dimming. C 2025 V1's light curve was bewilderingly complex. It wasn't a simple tumble. It pulsed with a strange, semi-regular pattern, with brief, sharp glints of extreme brightness. Some analysts suggested it could be a shard-like shape, but no natural model could perfectly replicate the observed pattern. The glints were almost like flashes from a flat, highly reflective surface, a feature not expected on a primordial piece of ice and rock. Then came the spectroscopic data, the analysis of the light bouncing off its surface. The results were stunning. While it possessed the basic signatures of water, ice, and carbon compounds, there were also trace elements of metallic alloys that defied easy explanation. Specifically, an isotope ratio of hafnium that, according to our understanding of stellar nucleosynthesis, simply should not be created in any known type of star. It looked less like a naturally formed object and more like a processed material, a slag heap from some unknown high-energy industrial process. It was a chemical fingerprint that pointed not to a star but to a factory. The global SETI, the search for extraterrestrial intelligence, mobilized on an unprecedented scale. Every major radio telescope from Arecibo's successors to the Square Kilometre Array was aimed at the approaching enigma. They listened across the entire radio spectrum for any hint of a signal, any whisper of a communication. The result was a profound and unnerving silence. No radio waves, no transmissions, nothing. But another type of search, looking for high-energy particles, yielded a tantalizing, ghostly clue. A neutrino detector buried deep beneath the Antarctic ice, designed to spot particles from distant supernovae, registered a faint but statistically significant triplet of events originating from the precise direction of C 2025 V1 Borisov. Neutrinos are notoriously difficult to produce in large quantities without massive energy sources. The bursts were not a message. They were too sporadic, too faint. But they were consistent with the decay signature of a theoretical power source, an antimatter annihilation drive. It was the barest whisper of an engine. This cascade of oddities, the improbable timing, the controlled trajectory, the strange glints, the unnatural chemistry, the neutrino ghost, pushed the conversation into speculative and for many uncomfortable territory. The hypothesis of an artificial origin could no longer be confined to the fringes. It had to be considered as a serious possibility. But if it is artificial, then what is it, and what is its purpose? The most elegant and perhaps most chilling explanation is the concept of a von Neumann probe. Named after the brilliant mathematician John von Neumann, who first conceived of self-replicating machines, a von Neumann probe is an autonomous robotic spacecraft designed to explore the galaxy. Its mission profile is simple and terrifyingly efficient. It travels to a target star system. Upon arrival, it seeks out raw materials, asteroids, comets, space dust. Using these resources and its own internal blueprints, it builds copies of itself. Once the replicas are complete, they are launched towards new, unexplored star systems, where they in turn will build more copies. This process of exploration and replication would grow exponentially, allowing a single parent probe to seed the entire Milky Way galaxy in a cosmically short span of time, perhaps as little as 500,000 years. Imagine a single sophisticated Lego robot programmed with one directive: land in a giant box of Lego bricks and build perfect copies of yourself. Then send those new robots into other giant boxes of Lego bricks. Before long, the entire room is filled with an army of automatons. In this scenario, C-2025 T4 and C-2025 V1 are not two unrelated visitors. They are part of the same grand, ancient enterprise. Perhaps one is the parent probe arriving to survey our system for resources, and the other, perhaps it is a newly manufactured offspring launched from a hidden construction site in the Kuiper Belt, now heading out on its own mission. Or maybe they are two probes from the same lineage designed to converge on a promising system like ours for a more detailed survey. The implications are staggering. It would mean the galaxy isn't just full of life, it's full of intelligent, autonomous machinery. We are not being visited, we are being assessed. Another slightly more benign possibility is that of a Bracewell probe. This is a messenger, a cosmic encyclopedia designed not to replicate but to find and communicate with emerging technological civilizations. It would travel silently from star to star, listening and waiting. Upon detecting the signs of intelligence, such as the radio transmissions we began broadcasting a century ago, it would activate and attempt to initiate contact. Perhaps C-2025 T4 was the initial probe, a door knocker sent to observe us. Its passage confirmed our technological status, triggering a signal to its companions C-2025 V1, the true ambassador, to alter its course and make a closer approach. The lack of an obvious radio signal doesn't disprove this. A civilization capable of interstellar travel may use a communication method we cannot yet comprehend, like modulated neutrinos or gravitational waves. Or perhaps the silence is the message itself, a demonstration of presence, a test to see how we react. The questions spiral outwards, each more profound than the last. What does this mean for us, for our future? The arrival of these two objects has resurrected the ghost of the Fermi paradox. If the universe is teeming with life, where is everybody? For decades, we have stared into a silent cosmos. Now the paradox has been flipped on its head. Maybe the reason we've never heard from anyone is because they don't use radio. They use couriers. And two packages have just been delivered to our doorstep. This potential revelation forces a kind of Copernican demotion on a scale we have never before experienced. First, we believed we were the center of the universe. Then we learned our planet was not. Then our sun was not. Then our galaxy was not. Now we face the possibility that not only are we not central, we may not even be the most significant form of life in our own solar system at this very moment. We may be sharing our home with an intelligence so old and so advanced that we are to it little more than interesting fauna. This knowledge could shatter our religions, our philosophies, our sense of self-importance, or it could be the single most unifying event in human history. Faced with a context so immense, an unknown so absolute, our terrestrial squabbles over borders, politics, and resources suddenly appear as the trivialities of a kindergarten classroom. The arrival of another finally forces us to define what it means to be us. It presents us with a choice to react with fear and tribalism, or with a unified sense of wonder and a collective ambition to meet the challenge. We are being forced to grow up to graduate from a planetary species to a cosmic one. As C. 2025 V1 Borisov continues its inexorable journey through our solar system, every instrument capable of observing it is locked onto its path. Its closest approach to Earth is still weeks away. Space agencies around the world are in a frantic collaborative race to launch intercept missions, small, fast probes designed for a flyby to get a closer look to capture an image that could resolve the debate once and for all. But the object is moving incredibly fast. The launch windows are narrow, the chances of success slim. We may get our answers, or the visitor may sweep past our planet and recede back into the darkness, leaving us with only its lingering transformative questions. We stand at a precipice of discovery unlike any in our history. The universe we thought we knew, empty, silent, and indifferent, may be gone forever. In its place is a cosmos that is more crowded, more mysterious, and infinitely more interesting. Two fleeting shadows have fallen across our world, cast by travelers from an unknown shore. For the first time, we know with certainty that the great interstellar ocean is navigable, and we know that things are crossing it. Whether they are messages in a bottle tossed by a cosmic sea, or the silent, purposeful ships of an unseen navy, remains the single greatest question we have ever had the privilege to ask. The universe has knocked, and for the first time, humanity as a whole is leaning in to answer the door.